Welcome everybody. My name is Will. I'm with S3RA Racing, and today we're going to walk through the build process to make one of these guys. This is a nano first-person view racing quadcopter, and it's great for indoor racing, and it's what we use as a part of our S3RA Racing Academy program for high schools and middle schools. So let's talk about some of these components. In the white box in front of you, you'll find your FPV goggles. These, if it isn't already obvious, are what you're going to be using to view what your quadcopter sees. In the box with your FPV goggles, you should find this little bag of goodies. If you have power at your table, it might be a good idea to get your goggles charging. Use the USB cable to plug into, I'm sorry, it's not a USB, it's a little DC input cable. You can go ahead and get those charging. By the time this afternoon rolls around, you'll be good to go. You'll also notice in this bag with your FPV goggles that there is an antenna that looks something like this. This is a special circular polarized antenna. If we opened this up, it would look like a clover or something like that. This actually screws into the top of your goggles using the little coaxial connection point. And this is the receiving antenna for the signal broadcast by your quadcopter. All right? You can screw that in now, and we're just going to set these aside. Go ahead and set your goggles aside. We're not going to do anything else with them. Hopefully they're charging. The other big box on your table has your radio. You should also locate somewhere on your table the batteries that go in your radio, just 4 AA's. You'll want to crack those open and put them into your radio. We're going to be talking about how the radio works here in a little bit. Some people call it a remote control, radio control, doesn't matter to me. This particular radio, I'm really excited about because a lot of the cheap radios that come with cheap quadcopters have no way to upgrade your system. This particular radio, inexpensive, sure, but it's a 6-channel radio that you can bind to a lot of other things. I'm going to go ahead and pop my batteries in here. I feel like this is kind of like a cooking show, right? We got the oven over here with the one that's done. Everyone's getting a sample. Really, this is like a cooking show. All right, so radio, batteries are in the radio. Just make sure it's not on. Keep it off. That way you don't drain your batteries. And we're going to set this aside as well. Other components that are important right now. Your charger. Your charger is important because we're going to get your flight batteries charging now so that by the time it's flying time, I guess that makes sense, you'll have something to power your quadcopter. You'll notice it's 2 parts. There's the charging board. There's also the AC adapter. These parts, I should mention, everything here today is distributed by Ready Made RC. They're a company based just north of Columbus, Ohio. They've been a great partner for our hobby for educational stuff. They give us a discount. They actually source and design a lot of these things. None of this would be possible without Ready Made, so thanks guys at Ready Made. Okay, so this charger has some really cool features. You'll notice that it has, this color-coded yellow connector. You can go ahead and plug that in. I know a lot of this stuff is probably obvious. We're going to go through it anyway. You can plug this into your wall. You'll also notice that there's a little switch on the board, and there's a 3S position and there's a 4S position. For the wall charger, we're going to leave that in the 3S position, and we're never going to change that. For most intents and purposes, that's all you need to know. Pro tip, this connection is an XT60 connector, and this is the same style connector if you've flown anything bigger, quadcopters, that the 2, 3, 4 cell lithium polymer batteries we use on those quadcopters use. So if you're flying outside or away from power, you can actually charge your small flight batteries with a bigger quadcopter battery. That's a huge plus. We in the hobbyist community were like, yay, finally we can do that. Okay. 3S stands for 3-cell, 4S stands for 4-cell. It has to do with the input voltage of the board. Okay, just leave it in the 3S position, that's fine. You're also going to find on your table, you have 5 of these little Strix flight batteries. Actually, you'll have 10. 5 for your starter kit and 5 from the pit kit that you all receive. There's our input voltage readout. Your batteries will fit into the larger ports. This board actually can charge batteries with 2 different types of connectors, JST 1.0 and JST 2.0. You guys have the 2.0s. Better because they don't wear out as quickly, they can handle more current. You'll notice when you plug in your batteries, red LED means I'm charging, green LED means there's nothing in me or I'm done charging. So go ahead and get as many batteries charging as you can. They charge in about, well, this first time they'll charge a little quicker because they're at a storage voltage. Batteries usually take about 20 minutes to charge. You can charge 6 at a time. Voila. You should have a bunch of propellers. Great. Set those aside, we don't need them yet. We have bags full of motors. Great, open one of those bags of motors and set those 4 motors aside. These are tiny motors that we're going to use to spin the propellers. They are in fact brushed DC motors. Brushed motors are generally less expensive, less sophisticated. They wear out a little bit quicker, but they're also the right size and weight for these quadcopters today. All right, so there's our motors. Yes, there are different colored wires. We'll talk about that later, so set those aside. Also sitting in front of you, you have a few different frames. I'm going to highlight these components that are up on the board right now, the white ones. For most of you, you might have a red one as well. Actually, we're not going to use this one either. This is like the Pro version. This is the latest revision of the S3 Ninja Star. This is something that we've designed from the ground up ourselves based on a ton of these little quadcopters. We've been, I don't know, 17 revisions deep at this point. Specifically with the design requirements that flying in an educational setting demand. Those requirements are things like easy to assemble, no additional hardware, relatively durable, needs to be lightweight because it flies obviously. 3D printable without messing with any special settings on your printer, basic high speed PLA, that's all fine. Yeah, there are other things I'll talk about, I'm sure, when we're going over this. There are 3 components. You have the main frame, propeller guards, some motor holders. You'll notice that there are some little tabs with arrows on them on most of your frames. Those are reference and we will be breaking those off later on. We also have a little camera holder and we have a battery holder. So we're going to use all of these components today. You can set any other frames aside for now. You'll have a couple, well actually you don't have the boxes. I'm going to show the boxes. Everything for you is in this box. This is your flight control board, the brain as it were, the microprocessor, the what have you. It's already connected to the power cable. That's a soldering thing that your teams will probably have to do. There are a couple other things in this box you don't have to worry about. One thing that it looks like apparently wasn't in the box was a micro USB cable. If you wanted to plug this into your computer to mess around with its settings, you could. We'll talk about that later too. In yours, your flight control board has generously been pre-soldered and attached to your first-person view camera, which is also combined with the video transmitter, or VTX. We're gonna go over this, how to like prep the wires and where to solder it onto your board here. But yeah, so get those components out, keep them close by. Now you will notice that you have a lot of extra parts. Each of your tables, each of you are taking home the complete starter kit and a pit kit. A pit kit is good for supporting one quadcopter for a season's worth of flying. Well, we'll see. It should. You have extra batteries, extra motors. I'm going to talk about my tools. So for this job, I have some basic tools here. Again, probably for today's workshop, you're not going to need all of these. Wire strippers or cutters. I like to use scissors actually sometimes. A little poker tool, more commonly known, actually less commonly known as an awl. I went to Home Depot and I said, do you have awls? And they're like, what? So anyway, poker tool. Needle nose pliers, helpful because these fingers are smaller than mine. And these little electronics tweezers are great if you don't already have this stuff at your school, the internet. Yeah. I also have sitting on my table a soldering iron. We will go over the soldering process here. All right, so solder. The smaller stuff is nice because we're soldering small stuff. Some of you might like to use flux. Flux is an agent that will help clean the surfaces that we're soldering. I don't use flux for this job. That's fine. We can talk about that later too. I also have a little hot glue gun. This one happens to be low temp. We're going to do a few little dabs of hot glue later on, basically to create the landing gear and make sure our camera doesn't shake too much. And I think that's the most of it. Oh, I also have this amazing piece of ceramic that my sister made for me. Yes, Kate, you're awesome. And if any of you guys use this like metal stuff to clean your soldering iron tips, you can buy the $8 copper version, or you can get the pack of 3 for $2 Scotch-Brite stainless steel pads, and they work just as great. Okay, so let's start the build. First thing we're going to do is stuff that probably you guys can just spectate because we're going to do the little soldering job. This would be 3 components. It would be the power cable here that connects the flight controller to our battery, which I have set aside and charging. The flight control board itself. This particular board for this demo is it's a B-Core version 2.0 for a FlySky radio. It's running, it's like the AHFDS 2A version because they change all the time. It's ridiculous. It happens to have a little bind button on top. Yes, there's a whole manual on this board linked in the document that you guys have. So if you have questions, again, you can ask. You'll notice on this board a couple important things. We've got ports to plug in each of our tiny little brushed motors. We have a little wire dangling off the front. Anyone know what that is? Antenna, that's right. This is the control radio antenna. This is how our quadcopter receives a signal from our radio controller to tell it how to fly, or how not to fly. It obeys your every command. On this board, there's some really cool things. Obviously, to have stable flight, we've got accelerometers, 3-axis gyro. It's running a microprocessor that actually runs a piece of software that's open source called Betaflight. We're not going to go too deep into Betaflight today, but just so you've heard it once, that's what it runs. Man, there are a bunch of other really cool things I'm sure I could talk about here. But I'm not going to. It does have this little bind button on top. I'll locate that on the top of your board. If I refer to the top of the board, it's the one with this tiny little button you can press. And if I talk about the bottom of the board, it's the one with all of the motor ports, the micro USB port, and the power cable. Okay, soldering time. I'm going to turn on my soldering iron, kind of get it going here. First things first, and you would normally do this to your power cables and the camera cables. Power cable's already soldered. I'm going to snip off the battery connector on the camera. We don't need it. And these are the world's worst snippers. Do you have scissors? Oh, hey, those are my scissors. Cool. These are my favorite strippers. So I snipped off the end of that. Where did it go? I just threw it away. All right. And now I'm going to just cut away a little bit of this wire wrapping. I really only need about 2 millimeters or so exposed. And I don't know if you guys are picking that up. Oh, cool, you can see it. Okay, that's about it. The next thing I'm going to do, if you were to look really closely at the tip of each of these wires, you would see that they're made of a bunch of little strands. I'm going to do something called tinning the tip of these wires. All right, so I've got my solder here, my rosin core, 60-40 solder. I'm going to add a little solder to the tip of each of these wires. It'll help hold those strands together, and it'll also make my soldering job later on a little bit easier. I wonder if I can also bring into view, nah, it's not worth it. This is my soldering iron, don't touch the hot end. I've done it before, it's not fun. When I move this out of frame here, it's because I'm either cleaning it on my sponge. It's kind of steam away all of the extra flux and stuff that's on there from the rosin, or I'm dipping it in this little metal mesh thing to clean off their extra solder. All right, so tinning the tips of these wires, that's what it's called. Solder's made up of tin and lead, at least this stuff is. My iron is hot. Okay, so I'm just melting a tiny bit of solder on the tip of each of these wires and looking for it to look nice and shiny. That's about it. All right, so the next thing is looking at our board. So for those of you who still need to solder, those of you at home or people watching this later, who need to solder on your power lead, on the top of your board, on the side kind of farthest away from the antenna, you'll see two little pads, one that's labeled ground and one that has two little pluses next to it. That's where you want to solder your power cable. You do want to make sure it sort of comes out the bottom of the board next to your USB port. Red is positive, black is negative. The other soldering job here is the camera soldering. And on this particular board, there are actually ports for soldering the camera specifically. Now on other boards we've used in the past, and who knows, maybe even some boards that you guys will get later on because sometimes they switch them on us, we would actually solder our camera leads to the same power leads, or to the same pads as the power leads. We just want to make sure the wires come out the top of the board instead of the bottom. You will notice it's labeled on the bottom, but we want the wires coming out through the top. So just make sure you identify the 5V, 5 volt, that's positive power, the GND, ground, that's negative power. You'll notice there are two other through-hole pads, I guess through-hole soldering jobs. They're labeled V out and I guess it says V in. That has to do with an on-screen display system. This board is capable of outputting data from the board to your video feed. These cameras will not accept that. So that's fine, we're gonna ignore it for now. Just make sure you're soldering to the right pad. So this is what we want here. 5 volt closest to the antenna, ground closest, or farthest away from the antenna, but I'm actually gonna solder it from the top side here. All right. So we're gonna see if I can get these started at least. Through-hole soldering is nice sometimes if you can get it through the hole. I'm gonna take a little solder. You can poke the wire through the hole and add solder to like the area in between the joint, or if the wire is kind of a little too thick, like it seems like it is here, you might just need a little extra hand to get that going. So I'm going to add a little solder to the tip of my wire here and get this to go in. Okay. All right, so double check that you have your camera leads attached to the right pins. I'm going to turn this over at 5 volts to the red, yep, and ground to the black wire, good. Give them a little tug. Make sure we have a nice physical connection in addition to that electrical connection, and this part of your build is good to go. All right. If, I guess, you have students that need to practice soldering, there are some great kits out there from like SparkFun has a couple really cheap, fun projects with LEDs and stuff. I'd recommend just checking those out and practicing your soldering a couple times before you do like the final soldering job on this guy. You're not gonna hurt it unless you plug in the battery and they're connected to the wrong leads. Another thing you wanna make sure you look at, make sure that after you've done your soldering, you don't have extra bits of solder maybe bridging the two wires or the two pads. If you do, you might cause a short, and these electronics are fragile enough that that could be enough to kind of fry your board. I guess at this point. It's also important to note that yes, replacement parts are available. No, Safety Third doesn't sell anything. Ready-Made RC does, and they will be later this week posting links to specifically these kits. They're actually going to be selling, distributing, shipping all of these kits specifically for our little experiment here in Northern Ohio. So those links will be made available to you guys too, in case something like that happens. Okay, so next thing we're gonna do is a little power up test, just to make sure we have our systems, all systems go here. So grab one of your flight batteries. No, it doesn't matter if it's all the way charged. And we're gonna plug it in, and we're hoping to see a couple things. Yeah, okay. We're hoping to see some LEDs on the flight control board. Doesn't matter what types of LEDs, just that there's power to the board, that's good. And we're hoping to see the little LED display on the back of your flight control, or of your camera, displaying some numbers and letters, all right? Go ahead and unplug. We're not gonna need the power just yet. You can put that battery back in the charger if you want. The next things that you guys are gonna need are the frame. All three frame components. And if you happen to have a poker, now you probably want your poker too. If you don't, I'm gonna attempt to do this with my fingers. We'll see how it goes. This is where things start to look a little more interesting. We're gonna start putting components in our frame. You'll notice your frame has some breakaway tabs. If you manage to get one of the frames that doesn't have breakaway tabs, probably your other frame has breakaway tabs. They're the same. These main members, these main structural members of the frame are angled in a way that makes them interfere less with the propeller wash. The front of the quadcopter is indicated by this middle breakaway tab, and if you don't have tabs, the front of the quadcopter frame kind of slants away from the inside. All right, so once you've identified the front, you can go ahead and break off that tab. I just like to wiggle it back and forth and twist it until it comes off. Save it in your pocket. It's a good luck charm. Okay, so we know which way is front on our board. Now we got to figure out which way is front on our frame. We need to figure out which way is front on our board. They have given us a little hint. There's a tiny little arrow on the board that points to the front of the board. Your other hint is the antenna comes out the front of the board as well. The power lead comes out of the back of the board. So this is the correct orientation, and we're gonna go ahead and install these. So actually, we're gonna try and bend this antenna kind of off to the side for now. You can snake it down underneath the board, that's fine. And actually, so this is a new component for us, this little battery holder. We're gonna start with this. I know, so we're gonna do the board, we're gonna start with this. It lays in on top of your frame like so. Eventually the battery will slide in from the bottom of the frame. So you'll notice, not like this, like this, okay? We're gonna set that in the top. It should be pretty loose. This thing is going to be pressed down a little bit, and it will eventually kind of snug up against those posts. So go ahead and lay that on top. Next thing is we're gonna snap our board on top of, and kind of like sandwich that battery holder in place. So you're gonna want to make sure that your power lead goes through the center of the frame. You wanna make sure your camera stays out, so that you don't let your camera fall into the center of the frame. And then we're gonna snap the board in place between all of these posts, all right? It's easy to start with one of these, and then you can delicately sort of bend the frame out of the way until you snap this thing in place. And if I flip this frame so you can see it from the front, you'll see our battery holder is sitting below our flight control board, okay? Feel free, if it looks like it does here, like maybe the board isn't snapped all the way in place, you can use a little bit of force and kind of push this frame together. That's what we're going for. On the underside, just make sure your antenna isn't trapped, like too trapped underneath your battery holder. It's fine if it just kind of flops around under here. All right. The next step is going to be to sandwich the board in place with this camera holder. There is a front to the camera mount. Like the shield looking camera mounty area is the front. Make sure that's pointing toward the front of your board. And this loops over each of these little posts and snaps in place. And if your wires are kind of in the way, you can kind of bend those down and out of the way. This is where, if you have fingernails, it might be helpful. You might want to use your awl, that's fine too. But you should be able to kind of press that over and then press it down on each of those posts. All right? And our board is sandwiched. At this point, it'd be a good idea to grab one of your batteries. We're not going to plug it in, but we are going to test the fit of the battery inside your holder. Notice when I'm putting this battery in for the first time, I'm going to kind of like pull down on the battery holder, flex it out of the way so I can push the battery all the way in. There's some tension there that holds the battery in place. That's what we're looking for. I just want to make sure everyone's, boards and everything are kind of snapped in place. All right, so I'm going to put that battery aside. So you should have your camera holder on. You should have your battery holder in place. This is the sandwiched look. Go ahead and snap your camera in place next. Just make sure the camera mount is facing forward. I'm going to go ahead and snap the camera in place so you can see what it should look like. You just press this in to the top, like that. I'm going to undo it and redo it. This is also our first hot glue innovation point. The camera will hold in just fine, but if you're concerned about a little bit of rattle, a small dot of hot glue goes a long way. Because this is not my kit, I'm not going to hot glue it, but you would want to put a tiny bit of hot glue, like right in the bottom of your camera mount area first. And while it's still hot, you just kind of press your camera right down in on top of it, and more robust. You'll also notice on the bottom of your quadcopter, your micro USB port should still be accessible. On other versions of this board, the USB port is actually not on the bottom, it's on the top, and in sort of asymmetrical fashion, which is why the arms of our camera mount are a little bit asymmetrical. It's adaptable, sure. If for some reason someday we get other board that has a component that interferes with one of these parts, they're 3D printable. Again, it's a very easy system to adapt. You don't have to go order a part online somewhere and wait 3 months for it to ship from China. The next step, we're going to install our motors and propellers. Orientation is important in this one as well. If your frame has arrows, yay. Yeah, some of the hard work is done for you. How I like to do this is lay out each component near each corner of my quadcopter in the right spot, so then when I go to actually install them, I have a reference. You'll notice with your motors, 2 of them have black and white wires, 2 of them have red and blue wires, and that's because 2 of them spin clockwise and 2 of them spin counterclockwise. Clockwise are the red and blue wires, counterclockwise are the black and white wires. In the documentation we have, it's illustrated in a really nice way. On this particular quadcopter, you want a clockwise motor in the front left and back right positions. As a point of reference, there is an arrow connected to each of your motor mounts that sort of points in the direction of spin. So for example, this arrow is pointing in a clockwise direction. This one is also pointing in a clockwise direction. Just a helpful reference. Counterclockwise, your black and white motors, that's your front right and back left. Okay? I'm going to leave this up here for a while. Your propellers also prefer to spin in one direction or the other. There are a couple ways of identifying this, and as you look at propellers more and more, it becomes very, very apparent. Each little winglet on your propeller, each blade of the propeller has a rounded edge and a flat edge, right? The rounded edge we call the leading edge because it's the first in its rotation to cut into fresh air. The trailing edge is that flat edge. It trails behind the leading edge. So if you imagine there's an arrow from pointing in the direction of the leading edge, you can see which way a propeller is supposed to spin. So for example, this one is a clockwise propeller. This one is also a clockwise propeller. These guys are counterclockwise propellers, because if you follow the direction of that leading edge, that curved leading edge, it looks like it should spin in a counterclockwise manner. Another way that you can check this is gently blow on the top of the propeller. It works even better if it's on one of your motors, which I'm not gonna do right now on camera, but it will spin if you're blowing on the top of the propeller the way that it's supposed to spin. All right, so once you have your motors and propellers lined up, something like this, you can go ahead and break off those little helpful reference tabs. Again, those are just good luck charms for you, for your pocket, for later. Okay, so next, we're gonna start installing our motors. So I'm gonna start with my front left clockwise motor with the little red and blue strands. And these motors push in from the bottom of your frame, all right? You'll notice that there's a little gap in the arms that hold the motor. They will bend slightly to allow you to press this motor into place. And it does take a little bit of force to open those arms up and get your motor in place. Watch that you don't accidentally poke the motor shaft through your finger on the other side. I've had it happen, it's not pleasant. And the motor will not go all the way through the motor mount. It sits just below the surface. There's actually a slight overhang on the top of those motor mounts that keeps you from pushing the motor all the way through, all right? So I don't know if you guys can see that on camera. I wonder if it'll focus for me. Maybe you can kind of tell. It's just below the surface of that. Okay, so once you have that motor in place, you can go ahead and put the other motors in place too. Just remember to try and line them up in the right positions. Does take a little bit of force here. The first layer on a 3D print is often just a little bit thicker than the subsequent layers to help with bed adhesion for those of you who are into 3D printing. So I'm going to work my way around my quadcopter, plugging in my motors. The motors spin the same direction on opposite corners of our quadcopter. If for some reason your bottom layer on one corner of your print is a little too thick, you can use a little like X-Acto knife or like razor or something to kind of shave away the bottom layer just a little bit. That's another thing with using 3D printed parts. They're easy to replace, but consistency kind of has a lot to do with your actual individual printer, your print settings, how it was feeling on that particular day, how much moisture is in the air. And I don't know if you're gonna get this on camera at all, if you guys can see, but I'm gonna, in general, cut away from my fingers because they're precious and kind of just shave away the inside of that bottom layer from my 3D print. Hopefully it'll give me a little bit better fit on this motor. Okay, for those of you who have already pushed your motors into place, they should be relatively snug. Yes, if you press on them too hard in one direction or the other, they will pop out. But for our flying intents and purposes, the thrust generated by the propeller actually pulls the motor up into that lip, and it prevents it from actually like pulling it through the top side. Okay, so double check. This is how I have this thing set up right now. Double check that you have red-blue wire on the front left, back right, black and white wire on the front right, back left. If I turn this over, it's opposite, but that's what we're looking for. All right. At this point, another little pro tip. This is not a required step, but I like to twist my wires to make them a little bit smaller, a little less able to tangle up in propellers and stuff like that. Generally, when you're twisting these wires, I would pinch kind of down near the bottom of the motor so you're not putting like extra strain on the contact points between your wires and your motor. But this is just a nice little step to kind of keep your build a little bit cleaner. So So I'm going to go ahead and do that on all 4 of these motors. Yes, it's possible to push the core of this motor out, the bottom of the motor. Again, they're small, little fragile pieces. You just have to be gentle when you're working with them, especially when we start putting the propellers onto the motor shaft. I've seen it happen a couple times where you're pushing pretty hard on the top of the propeller to get it in place on the motor shaft, and it actually pops the bottom of the motor out. Almost impossible to put them back in because the brushes in there are super, super tiny. It does make a nice little, microscope piece though. Show your kids how a brushed motor looks at this size. Okay, so I've got my motor wires all twisted. Now I'm going to install my propellers. Hopefully they're still oriented in that same orientation around the corners of my quadcopter. When I'm pressing my propeller onto the shaft, my motor shaft, I want to make sure I'm supporting the bottom of the motor with my thumb in this case. That way I don't accidentally press the motor out of the frame, and I don't push the bottom of the motor. I don't break the motor. So I'm going to go ahead and just press that propeller on. No, it does not need to go all the way onto the shaft. It just needs to go on far enough that it's snug, and if you blow on the top of it, your propeller should spin in the direction you want it to spin, in this case clockwise. So that looks pretty good. Another thing to do when you blow on the top of your propeller, listen. If you hear any clicking or snapping or anything like that, there's a good chance there's maybe a wire that's touching your propeller. It's a nice diagnostic test. We'll talk more about that later. So go ahead and press all of your propellers into place. And after they're in place, it's a good idea to, again, just make sure that your motors are all the way pushed up in your frame. It's easy to, kind of push things down when this process is happening. All right, so I've got my propellers in place. Looks like they're all spinning the right way. All right, we're getting close, guys. Next step, once your motors are in place, your propellers are in place, we're going to plug our motors in. And fortunately, we have motor ports that are located next to the motor that is supposed to plug into them. Wasn't always the case. It took us a while to figure that out. They got it right in this version of the board. The motor plug does fit into your motor port in one way and not the other. They have an orientation. So I'm just gonna not try and force it in place, but make sure that you plug in each of your motors to the port closest to that motor. And I'm trying to hold this so you can kind of see it too on the camera. It does sit like all the way down in that motor port. Okay, so I've got my motors all plugged in. My wires are not tangled up with my battery holder on the bottom. At this point, it might be nice to just kind of like bend them down a little bit, get them out of the way. All right, we have one last physical step to do, and our build is complete. We're gonna make some landing gear with hot glue. I'm gonna put a nice little glob of glue on the bottom of each motor. I'm gonna make sure it kind of covers the wires. This is gonna do two things. Your quadcopter lands on these motors. They're effectively landing gear, and this protects those wires from being bent out of shape after repeated landing or crashing for that case. If for some reason your frame, your motors are kind of loose in your frame, meaning like if you shake it, they kind of rattle around, or it's really easy to push them out, you can also use a tiny dab of hot glue on your motor to just keep it in place. We haven't found that it's necessary with these motor mounts. They're undersized, they kind of stretch, but like I've said in the past, hot glue fixes most things on a quadcopter. And the physical part of our build is complete. We're gonna bind our radio because that's one more step that you guys can do while you're sitting at your tables. Okay, so at this step, grab your radio control. Thanks for accommodating the last minute switch up. We're gonna go over the bind procedure for this quadcopter. I'm gonna leave my quadcopter upside down for now because it's got hot glue on it. All right, your radio has a couple switches on the top, toggle switches. We're gonna move those up for now. Unless they change something, which is entirely possible, up is the sort of like the off position, the default position for these switches. The left switch has to do with arming and disarming your quadcopter. The right switch will have to do with switching the flight modes. We'll talk more about that later. Just make sure they're up for now. These servo reversal switches on the bottom, make sure they're all down and they always stay down forever. The servo reversal switches will change the signal endpoints for each of the things that this thing outputs. So if I switch the throttle servo reversal, down is now actually up. It's transmitting as if this was in the up position. You'll also notice there's a bind button and a power switch. Don't turn it on yet. In order to bind our controller to our quadcopter, which is a process that ideally only has to happen one time, ever, unless you're binding this to multiple other things. It sort of makes a digital pairing between this unique quadcopter and this specific radio controller. To put this into bind mode, you hold down the bind button. It says bind key, that's fine. And then while you're holding that down, you flip the power switch. And you should see orange blinking light. If you don't, if you see green light, that means you didn't do it right. Turn it off, hold the bind key down, turn this on, let go of the bind key. Now this remote is in bind mode. It's looking to pair. Now, we can't do this all at the same time. We're gonna have to take turns. So I want you guys all to turn your stuff off so I can bind mine first, all right? Yeah. I'm gonna show you how this works and then you guys can do it. The next thing is we have to put our quadcopter into bind mode as well. And this is where it might be helpful to have another set of hands. There's a tiny bind button on the right side of your quadcopter, right? You should be able to, you press it with your fingernail here. You're going to hold that down while plugging in your flight battery. Oh yeah, there we go, okay. And then you can let go of the bind button.
Do you not do that right now?
Don't do that right now. I'm doing it right now, don't do it right now. Okay. If all went well, this thing is in bind mode, this thing is in bind mode, and they're trying to talk to each other. I usually wait 10 seconds. Sometimes it helps if the radio is not right on top of the thing. Sometimes you have to do this process once or twice before it'll take for whatever reason. Okay, the unintuitive trick here that took us forever to figure out is in order to complete the bind procedure, you have to cycle the power on the radio after they've been talking. So that means turn the power off, turn the power back on, and now what we're gonna check is, I should disarm, okay. So to check this, you should see green light here because you're powered on. We're assuming things worked well and it bound. You're going to use your top left switch to arm your quadcopter, which essentially allows you to do other things with these controllers. In this up position, your quadcopter is disarmed, meaning whatever I do with these control sticks, nothing will happen to the quadcopter. It's like the kill switch for your quadcopter. Note, if you crash, flip the kill switch so you don't spin your propellers. If you see magic smoke, hit the kill switch, unplug the battery, that kind of thing. All right, so I'm gonna arm my quad and just give a tiny bit of throttle, which maybe I waited too long here. Yeah, I probably did. You guys saw it spin up here for a second. Let's try turning this off. Back on. I'm gonna arm my quad. Is that actually opposite? I broke it. I did something. All right. When all else fails, turn it off, turn it back on again.
Somebody else has control of the controller.
It's entirely possible. Other rule of thumb, generally you always turn on your remote control first, and then you plug in your quadcopter. All right. Oh, there we go. Okay. I don't know what happened there. What you're looking for, and I wonder if we can see this on the camera. So I'm going to turn everything off one more time. Again, always have your remote control on before and leave it on until after you unplug your flight battery. So I'm going to turn on my controller again. I'm going to plug in my flight battery. There is a blue LED on top of your flight control board that will blink a few times while it's searching for a signal, and then it should go solid blue once it finds its paired signal. And that's your hint that you're good to go. I don't want you guys to take off once we go around the room and start binding and stuff like that, but as long as you're seeing your propeller spin, that means your radio is bound to your flight or your quadcopter, and you're one step closer to doing this. Okay. All right, so you should have your quadcopter, and we're gonna do this kind of regimented as a group. I will demo the procedure once. Don't touch anything on your desks just yet. As I kind of mentioned before, the video system on these guys is not digital. So there isn't a pairing process like we had to do with the remote and our quadcopter, like the flight controller. It's an analog system, meaning the antenna on the top of our quadcopter actually broadcasts a radio signal in the 5.8 gigahertz range, just like Wi-Fi actually. It's analog, meaning anything with an antenna tuned to the same channel can pick up that signal. Just like radio in your car, just like TV used to be, still kind of is, although it's digital these days. And what's neat about that is that with a single drone feed, like you're seeing over here on these screens, you can kind of see, anything that's tuned into that channel can watch it, which is pretty awesome. That means we can have people ride along with a pilot. We can have a ground station set up with video receivers that can capture 4 signals at the same time, put them in a split screen and up in a gymnasium during a race. That's what we will be doing later. But it also can cause some problems. If you have more than one person try to broadcast on the same channel, you get scrambled HBO. For someone who's flying around in the air, if someone in the pits plugs in their quadcopter, it broadcasts on the same channel, it could mean the person up in the air crashes because they lose their signal. So video frequency management is something, especially when you start flying with more than one person in the same space, you just have to be aware of. And it's something that takes some practice. We have some good rules of thumb to help mitigate that, but even today in races, national races with pilots who've been doing this for a while, video frequency management, and Frank would nod his head about this, is still always an issue. It's something we have to try and manage. All right, so let's talk about how to change video frequencies and stuff on your gear. So for this, you're going to want your quadcopter, obviously, your FPV goggles. If you haven't already installed the antenna, go ahead and do that now. And we're going to do this a couple different ways. So again, don't power anything on, but feel free to follow along with your quadcopter. As always, I'm going to make sure my remote is on before I plug in my quadcopter. That way it doesn't try to take off on its own. We've seen it happen. Plug in my quadcopter. And this time, I'm looking at the display on the back of my camera / VTX, video transmitter. What I expect to see are a letter and then a number flashing. Frequencies that this thing can transmit on are organized into frequencies and bands. So each band has 8 frequencies. Each of those frequencies relates to a specific frequency on the 5.8 gigahertz range. For example, F1, which is the first channel on the F band, is 5740. 5740 megahertz or 5.740 gigahertz. Okay, yeah, that's numbers, whatever. You can look that up on a chart. We have it in our documentation as well. For what we care about is making sure that the channel that we set this to is the same channel that we're receiving on our goggles, and it's also not going to interfere with the other channels we broadcast. There are channels that are close together and can cause interference, and there are channels that are far away that can cause harmonic interferences. The first year or so of FPV racing was the Wild West, and it took a long time for people to figure out which channels you could have on at the same time and not have interference. These days, yeah, it's great science. There's a lot of great stuff that you can read about it. These days, we like to use 4 channels on the F band. So we're gonna eventually switch this to broadcast on F instead of A. Are you guys seeing the letter and number on there at all? Okay, just trust me that there's an A and there's a 1 on there right now. The F band, and we're gonna use channels 1, 3, 6, and 8. I'll repeat it a bunch. And you're not gonna choose your channel. Usually during a race, the race director pre-assigns channels for each pilot, so you know ahead of time what channel you're supposed to be on. Okay, next question is, well, how do I change the channel on my camera, on my video transmitter? They can be a little bit finicky, but a short press of a tiny little button on top of your camera, and you guys can probably see that, a short press will change the channel from 1 to 2 to 3 to 4 to 5, 6, 7, 8, and back to 1. So you can kind of cycle through the channels. If I'm trying to make this one, I'm gonna shoot for F1. So I'm already on 1. A long press on this button will change the band. And again, I'm on band A right now. I need to get on band F, so I'm gonna do a long press and continue to press until I see F. A long press will put you into like change the band mode, and then you can just press the button until you cycle through to other bands. There's A, there's B, there's E, there's R, there's F. There might be a D on here also. You just cycle through until you see F. We're gonna talk about how to change the frequency here. So on these goggles, and we're seeing it, right? Yeah. So to turn it on, there's a power button. Just press and hold it really briefly until you see your screen turn on here. And on the inside, I know you won't be able to see this, but it's blue screen on the inside. That's fine. There is a button on the top here that will change the mode of your goggles. Right now, I see a blue screen, which means I'm in like AV mode. There is a way to actually like take an external video source and put it into these goggles. You might find an interesting use for that. To get it out of AV mode, I think we're gonna go into, I gotta look here. There's a menu button on top. If you press that button, you'll get into not AV mode, and you'll see, again, scrambled HBO probably on the inside of the screen. Do you guys actually see that? Cool. Okay. Now, changing the channel. So in the very top left, yeah, you're not gonna see it. Oh, you actually can see it. Kind of. Oh, you know what, it's in the documentation too. So in the very top left of your goggles, and you guys can do this with me, by the way. Don't turn on your quadcopters, turn on your goggles. In the top left, you'll see CH-R-2 or CH- some letter some number. That's channel, the band, and then the channel on that band. So you're gonna cycle through. For me right now, we're gonna tune to Fat Shark 1 because my quadcopter is on, and eventually you'll be looking at me in your goggles. So go ahead and cycle through. How do you do that? There's a button on the top of your goggles that's a channel plus and band plus. You can just cycle through until you have F1. All right, so I think as far as hardware goes, that's it. You guys have completed the build portion of this workshop. Give yourselves a hand. And now that you have your quadcopter all built, we're gonna talk about how your radio controls the quadcopter in the air. So if you look at your quadcopter, we've got a couple things going on. We have a couple switches. We already kind of talked about how this upper left switch will arm and disarm your quadcopter. This right switch changes flight modes, but the two business end sticks are right here in the middle. So on the right stick over here, we've got two other types of motion. You can move this stick up and down to pitch your quadcopter forward and backward, moving it forward and backward in space. And you can also move this stick left and right to roll your quadcopter left and right, moving it left and right in space. With all those motions, you can pretty much make your quadcopter do anything. Okay, so this is hovering. The only stick I'm really using here is my throttle stick. Slightly up on the throttle moves the quadcopter up, and slightly down on the throttle, quadcopter drops out of the sky. Slight adjustments with that stick make a big difference. Okay, the other thing my left stick can do is yaw. I can actually turn my quadcopter left and right, and you can kind of see it spins around. It's tricky to control your altitude at the same time as you yaw, because it's on the same stick as the throttle, but I think you get the idea. My right stick will allow me to pitch forward. I can pitch backward. And I can also roll to the left, and I can roll to the right. So here are a couple neat things that you can do with a combination of moves. Using only my right stick, I can pitch forward, roll left, pitch backward, and roll right, and I've completed a box maneuver, a box formation. All at the same time, I'm keeping the front of my quadcopter pointing away from me. Another way that I can fly is by holding forward with my right stick and turning by yawing with my left stick. And that's it. I'm continuing to hold forward with my right stick, pitching forward, and then yawing around with my throttle stick. This is a more sophisticated and smooth way to fly that is actually a lot closer to how people fly when they're flying FPV.